record. And off we go down to branches. So we talked about ways to get true and false, right? And how to use that to branch off in your program, do one thing or another. The Boolean type is what this all culminated in. That's the type of things that hold true and false. Okay? That's what Boolean is. And we talked about combining two Booleans with the AND operator. All right? So let's go there some more and talk about AND. So let's make a silly program that maybe would have worked over the weekend for whether or not we should bring an umbrella today. So we'll ask the user, hey, is it cloudy today? And hey, is there a chance of rain? And usually, if both of those things are true, we should say bring an umbrella. Okay? So that will be our silly program that we write. A should I bring an umbrella program? All right, and this is going to be one condition. Was it cloudy, and was there a chance of rain? So we'll combine those conditions with that double ampersand, which stands for and. So let's go make some code about that. Let me pull up the right notes before I forget. So I'll call this umbrella.cpp. So we got to ask the user, hey, is it cloudy and is there a chance of rain? So I'm getting two yes-no answers from the user, so I need two strings to store those. Cloudy and chance of rain. So these will hold yes or no, both of these strings. So see out, first question, is it cloudy today? Maybe a little bit. Again, get that word from the user, yes or no. Hopefully that's what they'll type. And then we'll ask them, is there a chance of rain? Sadly, not today. Chance of rain. So I'm getting two words from the user, stored into two string variables. And since I'm using the string variable type, string type, I should include the string library. So I've got those two words from the user. If cloudy is yes, if cloudy is equal to the string yes, like it was cloudy today, and they also, for the chance of rain variable, that got set to yes as well, so there was a chance of rain. In that case, we should tell the user to bring an umbrella. Only if both are true. Is the and of them true? Otherwise, if one of them was false or they both were, then we can say don't bring an umbrella. No need. Alright, so that'll be the program. Does that make sense? Combining those conditions. Is it cloudy today? Let's pretend it was the weekend. So yes. And is there a chance of rain? Totally. So bring an umbrella. If we pretend it's today, it's a little cloudy, but there's no chance of rain. So since one side is false, this part fails. The and of true and false is still false. Okay? And every other combination. That isn't both yeses. Okay? So that's how that works and executes. Any questions about that one? All right. So that's one way of combining conditions. They're both true. That's the and. There's another word we use in English a whole lot, which is or. If one thing is true, or both, then let's do something. So let's combine conditions with this operator, and this is called the or operator. Two pipe characters. It's that key above your enter key. So let's ask the user, is there a chance of rain, or is it currently raining? Ask both of these questions. And if either one is true, then they should probably bring an umbrella. Right? So hopefully the forecast isn't lying. And if it's currently wet outside and raining, you should definitely hold an umbrella in your hands. So that's what or is good for. And so here's the truth table for the or operator. If we get, hey, let's pretend A is chance of rain and B was currently raining. If they're both true, you should totally bring an umbrella. If there is a chance of rain but it's not currently raining, well, it might rain later. So let's have them bring an umbrella. That will be true. True ORed with false is still true. It's just as long as one of them is true, the or of them is true. False ORed with true, no chance of rain, but is it currently raining? We still want to say bring an umbrella, so it's going to be true in that case. The only way to make an or false is to have both sides of it false. False ORed with false. That's the only way to make false. And it's okay for both of them to be true, by the way. But yeah, it's true if any of them are true. Both, one, or the other. So that's or in a nutshell. it produces true if either side is true. So let's make another umbrella bringing program and try this one. Umbrella 2. So I'll still get, is there a chance of rain? And then I'll also ask the user, is it currently raining outside? That's important. So let's get that one. And then, is it currently raining? So just getting yes, no from the user into these aptly named variables. And so if the chance of rain is yes, if there is a chance of rain, these are typed yes for that part, or maybe this is or currently raining is yes. They type yes for that. If either one is true or both, then we should say bring an umbrella. Okay, that's the or operation. Oh, sorry, and I called this umbrella 2. Is there a chance of rain? Yes, but maybe it's not currently raining. As long as one side is yes, as long as one of these is true, this one is, it makes the whole or together true. Is one or the other true? Yes. If they're both true, yes, bring an umbrella. If the first one's false, but the second one's true, still bring an umbrella. The only way to not bring an umbrella, the only way to make it false, is for both of them to be false. For this side to be false, or with false. You're asking, are either of them true? The only time that's not the case is when they're both false. All right? That's the or operation. Questions about that one? Similar to English, kind of. So or is good when you have little distinct chunks that you want to check for. Like I want to check for this thing or this thing and make this code fire when that happens. In either case, maybe they're not next to each other. A common example would be like you have a number line, you're getting numbers from the user, like here's negative 50, here's positive 50. And you want to do something special if the number's within this range or within this range. Either way, do something special. Do a special blue thing. The way that you would check for this is like, is the number within here or is it within here? You'd have to section it off like that. Okay, that's what or is good for. So I did and, I did or. There's one more big one that we need to talk about that does fancy stuff with your trues and falses. It's called the negation operator. It's called the not operator. It's the exclamation point. You read that as not, which is exactly why I told you to read that as not when we did not equal to. So that is the negation operation, because sometimes it's easier to ask a question about whether something's false rather than if something's true. And so the negation operation just flips false to true and true to false. It does the opposite. That's its truth table. All right. So I should give you eventually an example of that, but let's use code for a second. So here's an example of asking an equivalent thing. So you could either say, maybe sometimes for your program it's easier to ask like, I want this thing to happen when it's not true that A is less than B. So you can just if that's what's going on in your brain, you can immediately write that. I want it to not be true that A is less than B. You put not right next to it. And so whenever that's not true, it'll give back true. So whenever this is A less than B is false, it will give back true. That's the whole point of not. So that will make sense eventually. And there is a way to write this without the not. You can check the opposite of less than is greater than or equal to. There's another way to go there. But not is totally possible. And let me prove that to you for every possibility. But those are equal things. And this will also help us learn about not. So, all right, let's pretend A is strictly smaller than B. So A can be 40, B can be 42. Let's pretend that the opposite's true. And then let's pretend they're equal to each other. So those are the three possible cases for A and B, as far as where they might be relative to one another. And so let's do, what's A less than B for all these cases? If A is 40 and B is 42, A less than B, that's true. This one is 42 less than 40, no, false. And then is 40 strictly less than 40, no, false. All right? And so that's one way to do it. And then if we negate that, say not A less than B, it takes this and it flips true to false and false to true. That's what the negation operator does. And so If we say not a less than b, and I have what a less than b is, I just take that and flip it. This becomes false, this becomes true, this becomes true, right? And then what I'm trying to prove that this is equivalent to a greater than or equal to b. What's true about this? Is 40 greater than or equal to 42? No, false. Is 42 greater than or equal to 40? Yes, true. Is 40 strictly greater than or equal to? Strictly greater than or equal to 40? Yes, totally, it's equal to. So true. And they agree, so they are equivalent. That's my silly proof. But that's what the negation operation does. It's like, I have this, but I actually want to do the opposite. I want true when it's false. Okay? That's what negation means. I want to like put this in an if statement and say, if it's not true that A is less than B, do something. Alright? Any questions about that? It's a weird one because it's backwards. But that's the idea. Alright. And alright, that leads us into a nice new topic called precedence. Because one day you're going to write a giant if statement and you're going to not put any parentheses anywhere and you're going to wonder what is going on. And so it's my turn to tell you what's going on. So you know this from math, right? You do like 5 times 7, maybe that's in parentheses, divided by 3 plus 4. You know that there's an order of operations for math. The same is true for computer science. The same is true for our programming languages. So like if you write this, A less than B and B less than C, or C mod D is equal to 42. Like who knows what this is doing? Maybe it's like comparing B to this big thing. You have no clue until you learn about precedence. So let me show you. All right? So precedence is all about, you know, you can have things happen in any order if you draw parentheses. So essentially, the idea of precedence and order of operations is how are parentheses going to be drawn before your code gets run. That's how it works. So it's an order of operations for programming. That's what the word precedence means. What operation precedes another operation. And here's the trick. I'm going to give you a big long table in a second, and we'll read off the precedence order. But here's how it works. In the order of precedence, some things are more important than others. They happen first. In the order of precedence, every operator, it's going to take the smallest thing that it possibly can to the left and the right of it, and that's how it's going to draw its parentheses, right? Just keep that in your mind. It probably doesn't make sense until I give you an example, but that's the phrase. It's going to grab the smallest thing that it can to the left and to the right, all right? So let me show you the table. And I'll give it to you right now, too, by the way. If you go to the Lecture 5 page, I will clear out the video, because there is no video yet, and clear out the slides, because those links won't work yet. But I will give you this precedence table link. Save and publish. So you can go here now. It's available on Canvas if you would like. But here is the file, precedence table.pdf. I'll open that up. And here it is. It's a big long table. There's a bunch of different sectioned off chunks. Things within a chunk are the same precedence level. You just do them from left to right. But like that thing happens first, then all of these as a group, then all of these as a group. And then here's like math, multiplication, division, remainder, plus minus, see out stuff, insertion, extraction, less than, greater than, equal to, and, or. They're separate. But the things up top are higher precedence. They happen first. The things down towards the bottom are lower precedence. They are done towards the end. They happen last. Right? So assignments at the very bottom. So that's the precedence table, and we'll consult it for some examples. Right? Here are my examples, and it will have this phrase make sense. Grab the smallest thing it can to the left and to the right. Right? So let's do math first. Let's read all this stuff off the precedence table. So first, what are my operators in this expression? I have times, modulus, and plus. Now I got to go find them in the precedence table to see what the order is. All right. So here is multiplication and remainder. Those are at the same precedence level. So it's just whichever one's on the left happens first if there's a tie between them. And then addition and subtraction are in their own group. So these ones happen first. I'm going to deal with, looks like the order that these are going to apply is 1 is multiplication because these two are at the same level and multiplication is to the left. Then we have modulus. That's at the same precedence level, but it's more to the right. So that's the second thing that's going to happen. And then the addition is a lower precedence, so it's always meant to happen last. So that's the order of those operations. And now, what are they going to do? What is going to be multiplied is the next question. What's the first thing that happens? And so the idea is this multiplication operator is going to look to the left and to the right of it and take the smallest thing it can. All right? So there's only one thing on the left of the times. It's the 5. It's taking the 5. So it's going to draw a parenthesis there. And then the question is, what does it take on the right? Does it take 7 mod 3? Does it take 7 mod 3 plus 4? No. It's going to take the smallest thing it can, which is just the number 7. That's what's going to happen. That's what's going to be multiplied. Does that make sense? That's what I mean by smallest thing. All right? And then next, after that's done, it's Mod's turn. It's going to take the smallest thing that it can to the left and to the right. Its hand has been forced for the thing on the left. You can't like take the 7 somehow. You're forced to take this whole parenthesized thing on the left. So that's the left side of the mod. And then on the right, it doesn't want to like do all this. It wants the smallest thing, so it's going to take the 3. It's going to do all that mod 3. That's the smallest thing it can put on the right and take as its right side. Okay? So that's how that's going to work. And then it's plus. Don't really need to draw anything, right? It's already been parenthesized. So it's going to add this thing, whatever that result is, to this result. Any questions about how I read that off the table and drew my parentheses? Because that's going to be the order of operations for that code. Ready for the hard one? All right, so find all the operators is the first question. Less than, and, less than, or, mod, equals to. All right, where are all these? Looks like mod's going to happen first. It's up top here. And then a bunch of relationals. So we got less than, greater than, less than equal to, greater than equal to. Apparently these ones are higher precedence than the equal to's, which is funny. So it looks like we deal with less thans first, from left to right, and then it's equal to's turn, because it's in a lower precedence level. And then we got and or left, and so and happens before or. That's the ordering. So let's deal with all those. We do our relationals first. So we got A less than B and B. Oh, sorry, we do mod first, excuse me. That's way up here. So that's math. So that happens first. So mod gets to go first, and it's going to take the smallest thing to the left and to the right of it. It's not going to be like, let me modulus this with all this. It's going to take the C and the D. Yeah? That's how that'll work. Next, all right, we have a bunch of these other ones. They're all in these rows down here. So we got less than. That's going to be happening next. And we just go from left to right if there's a tie, if there's two less thans, or two things in the same level. So this one gets to go first and take its smallest thing to the left and to the right of it. So it's going to take the A, and it's not going to take this whole thing. It's going to take just the B, the smallest thing it can take. Okay, so that works. Then this one gets to go, smallest thing to the left and to the right of it. It's going to take B and C, of course. And then we have what is unparenthesized still, and or and equals to. So what's the ordering? Equals first, it's higher precedence, it's above, so that happens first. And so we're going to compare not all of this to 42, but just this left parenthesized thing to 42. It's going to take the smallest thing it can to the left and to the right of it. So that's that one. And then it's and or. Who goes first? Let us consult the table. So and gets to choose first. It has higher precedence than or. So all right, and gets to take the smallest thing it can to the left and to the right of it. It's going to take this guy and this guy, right? It's not going to take all this on the right. It's going to take this and this. Okay, and so now it's happy. And then or, it's essentially done at that point. It's only got one thing to the left and to the right of it now that it could possibly take. So it's or's turn to go last. And it's going to or together whatever this result is with whatever this result is. Okay? And that's how you use the table and figure out how this is all going to get executed. Are there any questions about that? All right, your turn. There's a reason I'm teaching you this. It's not just obvious, I promise. Here is a good example of that. So here is some code. I encourage you to run it in your mind. But here's like something that would be part of a condition or set to a Boolean variable. So do number 1 and 2 as a group, and then I'll start the by-clicker for the first one. But please share your answers with me as well. So I'll start that. All right, but you know where the precedence table is? Lecture 5 link, if you want it. Here are your two expressions. Draw the parentheses. Assume that x is 5 and b is set to true. Is this true or false? And is this true or false? Any questions about the question? All right. So give those a try. Do the first one, and see if you can enter in your answer. I'll give you a couple minutes to try both, and then we'll come back and enter in our answers. And help the people next to you. Say hello. Why would I be asking two separate questions? Take another minute, let's say. We're not very talkative, so that must mean we already did it, right? So take one more minute to share answers, and then we will continue. All right, that's my timer. Please get your best guess in for the first question. Give you a few seconds for that. And did everybody do attendance? I'm about to stop attendance too. So do that now if you forgot. After this question, I'll end it. All right, what are we thinking for this one? We are not sure. Slight majority think A, though. Okay, that's question one. So we think it might be true. All right, let's try number two. What did you get for number two? Enter in that answer. Give you 15 seconds or something. Should be on the page, right? What did you get for that one? Is it the same? Is it different? Weren't so sure. We think it might be true for the first one, but we were definitely unsure. We're very sure about B. Interesting. Okay. Very, very interesting. Thank you for playing. Fun. All right. Back to where we were. Let's do it. Let's do it together. Did any questions come up that won't be answered as I do it? All right. So, okay, X, we're assuming X is set to 5. X is a variable, holds 5. B is a variable, holds true. Assume these. So, all right, let's, first of all, how are the parentheses going to be drawn? Let me just do that quickly. Addition's happening first, then we're going to compare, do these comparisons, blah, 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 addition, comparisons. Not very interesting, but you get the idea. And then this one's forced or to come before and what's the default, though? And happens before or if I didn't put those parentheses there. So, all right, boop. That's how the parentheses will be drawn for this one. And that's probably going to make all the difference. Otherwise, why did I ask you this? All right, let's figure this out. X plus 1, that's, if X is 5, X plus 1 is 6. Is 6 less than 8? that is true. This little bit right here, that's true, T for true. And then is x strictly greater than 5? No, it is 5, so it's false for that piece. B, what's that? That's true by itself, so it just gets replaced with true. That's the variable. And then true ANDed with false. Anything ANDed with false is false. So this whole thing becomes false. And then we're doing true ORed with false. That's the last step. As long as one of those is true, the answer is true. So I get a T there. So good job. I think a slight majority got true, and that was the right answer for the first one. Good. All right, so let's try the rest. So this was true still, right? True. This part was false because x is 5. And then here's B. B was true. Cool. So when I OR these, true ORed with true, as long as one of them is true, the whole thing's true when you do the OR. And so the last step is ANDing true and false. And oh no, unless they're both true, the AND is false. All right, so one false ruins the day for that one, for an AND. And so the result is false for 2. We seem to get that one. Any questions about that? So that's the precedence order, and it's in a separate box from OR. And so AND is going to happen first, even if it's over here on the right, unparenthesized. We say it binds tighter. It's grabbing things first compared to OR. Right? So when in doubt, you probably should be drawing your parentheses. Just write them into your code so you know what's happening. That's probably the most helpful lesson here. But that's that. All right. And now that we know about precedence, some ideas that we might want to have work, we know why they don't work. This code, like, we wish this worked and it did something like, hey, check, is x 3 or 4? One of the two. This does not work. All right. Let me show you why. It's going to draw parentheses like this. Equals binds tighter than OR, which is down here. So the equals gets to go first. So it's taking the x and the 3. And so we're checking this. Hey, is x equal to 3? Is that true, or is 4 true? See that? That's not right. Any number is always true, so this whole thing becomes 4. This whole thing becomes true. You're not checking is x 3 or is x 4. You're checking is x 3 or is the number 4 a true number? That's wrong. If you want to check is x 3 or 4, you have to do it like this. Check if it's 3 or if it's 4. That's the right way to do it. All right. So that's a common mistake I've seen. So this is how you check, is a number one thing or another? You got to put the equal sign twice, sadly. All right, I think that's all that I wanted to say about precedence. Are there any questions about any of that before I just switch gears to something else? Now we know it, at least. So I have some just longer examples now that combine all the stuff that we've been learning. Let's go through them. The first example is a program called FizzBuzz, which is an exciting program. It's something you have to learn as a computer science student. It's a standard example. It used to be like a very common interview question, just to write this special kind of program that does this. And so here it is. It's too easy now, so we teach it in CSCI 40. So here's the game. It's called FizzBuzz. We're going to get a number from the user, and the game is we're supposed to print out fizz if that number, call it n, is divisible by 3. So we're printing fizz if it's divisible by 3, whatever that number is. We're going to print buzz if that number is divisible by 5. And if it's divisible by both 3 and 5, I'm going to print FizzBuzz, not just fizz, not just buzz. I'm going to print them both. Print FizzBuzz if it's divisible by both 3 and 5. Right? If none of that's true, just print the number. All right? So that's the game. It's like if you type 1 or 2, none of those are divisible by 3 or 5, so you just print the number out. If you type 3, though, you're printing fizz. If you type 4, still printing 4, there's nothing there. No common factors. You print, if it's divisible by 5, you print buzz. And then same for multiples. So like you see 6, that's a multiple of 3 only. So fizz, same for 9. 10's a multiple of 5 only, divisible by 5, so you print buzz. But then once you get to 15, now it goes in, 3 goes into it, 5 also goes into it. It's divisible by both 3 and 5. So you're going to print FizzBuzz for 15 and 30 and numbers like that. All right, so that's the game. I hope that makes enough sense. And the way that you check in like an if statement, is a number divisible by another, is you try to divide it. Use the modulus and check if it goes in cleanly. So we already checked even and odd. Another name for evenness is divisibility by 2. A number is divisible by 2 when it's even. So you try to divide it by 2. If there's nothing left over, if it went in cleanly, it was even. All right? It was divisible by 2. And so that same pattern works for everything else. This is how you check if a number is divisible by 3. Try to divide it by 3. Look at the remainder. If it was 0, that means it went in cleanly. It was divisible by 3. Okay? Does that make sense? That's how you check for that. And so a similar one for 5. So that's that. Let's see here. I still need to change this everywhere, sorry. On the written ice page, let's go to the written ice page. So I have a question for you. Here's an implementation of FizzBuzz. This is probably looking good, but there's an error. There, cleared out written ice page. So here's code. This is like the obvious implementation of FizzBuzz. Assume I got n from the user already. He's like, all right, I'm checking. Hey, is it divisible by 3? Print fizz. Otherwise, else if. If it's divisible by 5, print buzz. Else if it's divisible by both 3 and 5. If this is true and this is true, see how I'm using the and, then print fizz buzz. Otherwise, if none of that's true, print just the number. All right. So this is like the obvious implementation going down these rules. There's something wrong with it though. See if you can find it and try to explain why this code is not going to do the right thing. See if you can find some counterexamples. Try running it in your mind. That's the best practice you can get. But I will give you an explanation in just a second. So take a couple minutes, stare at the code, see if you can convince your neighbors that you found the problem, and then we'll talk about it. All right? Better write it down. What's wrong with this code? Except for this missing new line. That's wrong. Oh no, I did end up. Sorry. No, that's correct. I just did backslash n because I was lazy. What's that? Yeah, gotta keep us on our toes. Remember the game. Divisible by 3, fizz. Divisible by 5, buzz. Divisible by both 3 and 5, fizz buzz. And then none of those, just print the number. A few weeks, I would say. Yeah, it's not normal because like this is flat, this is a little tilted, and like you do one thing here and it translates there. It's weird. Yeah, exactly. It's right there. It's a jump, definitely. Do we see it? We do have access to computers in front of you if you wanted to try it. But yeah, take a few more seconds, think about it. And then I will tell you what's wrong. Let's see if anybody brave enough to write something on the page. Thank you if you did. But it's alright if you didn't figure it out. This is a harder question. Ooh, nice. FizzBuzz should be first. This has to come first. There's an ordering issue. Very good. Nice. So awesome if you saw that. Thank you. And that is the problem. So let's talk about it. All right, what's going on? So let's draw a diagram of how this code is going to execute right now. Do I want to code it up first? Give me a second. Let's see. Yeah, why not? Oh, let me code it up. So then it might help, I think. Yeah. So there's an ordering issue. I'm going to draw a diagram in a second, but let me just prove to you there's a problem. I'll call this fizzbuzz.cpp. So I'm going to get a number from the user, call it n, I guess. CInit. I guess we need a prompt. So cout, enter a number, colon space. And then, alright, if, we're going to do this in this order. If n mod 3, if it's divisible by 3, then see out fizz. Else if otherwise, if it's divisible by 5, print buzz. Else if otherwise, it's divisible by both. So we got this one and this one. And now that I know precedence rules, I know I don't need any parentheses. It's all going to do what I want. Fizz buzz. Otherwise, this one was fine. Just output the number if none of that's true. That's in the right order. But the rest of these are kind of out of order. Let me show you that. The secret is, if you type a number that's divisible by both. 15 is just going to print fizz right now. Do you see it now? You didn't see it before? 15 is printing fizz. Alright. So let's draw how this works. So we got a number. How does this code execute? We're going to do, the very first thing we do when we're executing in a big long if else is we got to figure out which one to do, so we just try the conditions in order. So we're going to try this condition, check it first. So the very first check in the code is, we check, hey, is n divisible by 3? N divisible by 3, that's what that condition is checking, question mark. And if that's true, if it is, yes. If it's true, we're going to print fizz. Otherwise, if that's not true, then the next thing we do is we try this one. We've got to check its condition to see if we need to run its body. So, alright, is n divisible by 5? If that's true, then we'll print buzz. If that's false, so that's the false side, this is the true side. If that's false, we try this one. Otherwise, check if they're both divisible by 3 and 5. And I think you see how we got here, right? This is kind of useless, but let's keep on going. Is n divisible by 3 and 5? Question mark. That's the next thing it'll check. It's just going to do that in that order. If that's true, it prints fizz buzz. If that's false, that was our last check. We're just going to go straight to the else's body, and we'll just print the number. Print n if it's false. And the issue is, what if n is 15 or something that should be printing fizz buzz? The very first thing that's going to happen is this check, is n divisible by 3? Is 15 divisible by 3? Yes, it's divisible by 3 and 5. So it's going to hit the true branch and it's going to say fizz and then be done with the whole thing. See that? So the secret is the order. Make the hardest thing possible happen first. The thing that might be overshadowed by other things, that better be the first body. This better be the first condition. You see that? That's how you fix it. So let's go there, and let's make sure that that's the first thing that we check. So is it divisible by 3 and 5? It's got to be the first condition. Because the other ones kind of like overshadow it. It's already there. Alright, so then this one can be just fizz. Let's do some surgery here. And then this one can be fizz buzz. There. And that's the correct order. Now it's happy, no matter what. If I type 15, it's fizz buzz. 2, it's just 2, 3, or 6 or something, I get fizz. 5 or 10, whatever, I get buzz. But any multiple of 3 and 5, now I'm getting the fizz buzz because that's the first thing I check. Right? And that needed to be the first thing that I checked because this is a weaker condition, right? It's always true if it's divisible by 3 and 5. Same with this one. So do this one first if you want something to happen if they're both true. Otherwise, this one will always be true. All right? That's fizz buzz. So that is a fun example. Shows you the importance of ordering your conditions. And that's that one. Are we good to move on to some more examples? let's do string stuff. Let's go back to string stuff. Let me talk to you about how strings are compared. You can do equals on strings, sure, but did you know you can do less than on strings? Why not? So strings are compared. You can ask like, hey, is ABC, let me go back to blue. You can ask this to C++. You can put this in a condition. Is ABC, is that less than BCD? These are both like string variables that produce these. And this is going to be true because it's going to use what's called lexicographic ordering, which is a fancy Greek rooty way to say dictionary order. Okay? So that is just going to compare these two. Like, would ABC come before BCD in the dictionary? Yes, because the A is less than the B. And then you would also know why like AAB is going to be less than ABC. Because like if the first character is the same, you start looking at the second one and compare those. So again, that would be true. Technically, it's comparing using ASCII code values. So it's a little disgusting. Like the character for 0 does come before the character for lowercase a. And I think capitals come before lowercase ones in the ASCII table, right? And so capital A would be less than lowercase a string, so that's a little disgusting, but that's how that works. That's the ordering of those things. Let's see, do I want to? So that's just that, if you care. And then I have two ideas for demos. So let's take a word and capitalize it. Convert it to a proper noun. Let's like have the user enter in their name, and maybe they forgot to capitalize it, so you get a string like with my name. And then let's always capitalize it to its uppercase version. Let's capitalize any lowercase letter using a better strategy than the one I showed you with ASCII math. There's a nice little function for us in the CC type library. So let me show you that page. C plus CC type. So this is a fun little library. Oh gosh. I hope I didn't just click the wrong thing. And here is some nice functions. They work on characters, individual characters. These are functions that give back true or false. Like, is it an alphabetic character? It takes a character, gives you back true or false. And for some reason, the character, it takes it as an int, and for some reason, instead of bool, it gives you back an int for true or false, but that's okay. It gives back whether or not it's an alphabetic character, whether or not it's a digit character, whether or not it's a lowercase character. These are very helpful little functions for us. But what I need are these characters that change things, called toLower and toUpper. I'm going to use the toUpper function. What it takes is it takes a character, and if it's a lowercase character, it gives back a capitalized version of that character. It's taking an int and giving back an int for a very weird reason that I don't want to get into. Just imagine that it's taking a char and giving back a char. Okay? So that's that, and we're going to use that. We can call toUpper on a character and have that give us back the uppercase version, so I can then go and mess with it. All right? So like, let's say I get a string S, and I want to capitalize the first character of it. Like, I don't know, it's A, B, C, and then a 5 or something. I want to capitalize this A. I can go to index 0 of that string, call toUpper on that character at that index, and then whatever it gives back to me, just plop it right back in. If it's already capital, it'll keep it the same. Or if it's a non-character, if it's like a digit or something, it'll also keep it the same. So it's a nice little function. So let's use it. So this I'll call strings.cpp. And surely if I want string variables, I need the string library. But I'm using CC type functions. I'm going to include this for toUpper. Now I have access to it. So let's get a word from the user. Cout, enter a word, your favorite word, potentially lowercase. And now let's capitalize it. Capitalize the first character in S. Right? So the first character is always index 0. So we're going to go there, figure out what's there. It's like S at 0. That's the first character. The capitalized version of S at 0 is just me calling toUpper on it. This is the capitalized character, whatever was there. All right? Then I want to take that capitalized character. Oh, sorry, toUpper. Sorry, it's just by itself. toUpper. There it is. So that's the capitalized version of it. And then I just want to put that back at that index. S at 0 equals the toUpper version of itself. That's the line. Does that make sense? So now if I print S, it will have been capitalized if it wasn't already. Yeah, so enter word, lowercase my name becomes capital my name. If I already give a word that's capitalized, it doesn't touch it. The to-upper just gives back that same character still, and the same if it starts with like a digit. So it'll just always work and capitalize the first character if it needs capitalizing. So that's what to-upper is good for. It's a nice, helpful library function. We good with that one? Just, you can put that away in your mind. You know about it now. Let's have this demo now. Let's say that we get a string from the user. We already did. Let's check if it ends with a number. Let's see if it does. How do you check that? It's like I'm getting a string from the user. It may be my name. It may be size 6. It may be ABC5 and size 4. How do I figure out where the last index is? I think I kind of gave away the answer in my explanation. How do I find this index? Because that's the index of the last character. I need to check that one specifically and see if it ends with a number. If it's this one, it's index 3. If it was this, it would be index 5. Like, how do I know which one's the last index? Any ideas? Are there any functions or library things we could use that we know about? So I need to find that number to get that last character. It's got an index. It goes 0, 1, 2, 3 for this one. But if this was my string, it would go 0, 1, 2, 3, 4, 5. How could I get 5 or 3 depending on the string? What are our thoughts? Why is it 4? Why would this one be, or why is this 3? Why is this 5? What's the difference between these strings? Tell me that. That's the easier question. Why is the last index of this one 4, but the last index of, why is the last index of this one 3, and the last index of this string 5? What's the difference between those strings? Somebody tell me. Yeah, one's shorter than the other. One's longer than the other. That's all. And so the way that you find the last index has to do with you figuring out how long the string was. Right? Do you remember the library function? The thing on, it's a method on the string object. If you want to use the fancy terms that I'll talk about later in this class. If you do s.size, that will tell you how long the string is. Remember that? That gives me for this one 4. The last index, because it started at 0, is like 1 less. So it's s.size minus 1, and that will always work, regardless of your string. Because if this is size 6, that minus 1 gives me 5, which is the last index. Do you see how you can use size to find the end of your string? That's important. All right. Check if a string ends with a number. That's my job. So I've got my string already. Let's check if it ends with a number. And so if something, some condition, if that's true, then it does. We have to come up with something that gives back true if s ends with a number. That's one way. And then otherwise, if that wasn't true, our fancy condition, then we'll say it doesn't end with a number. So sad. All right, so how do we get the last character? Because we need that first. So it's s at some index. What is the last index of s? Always, it's at size minus 1, regardless of its size. This will give me the right index. So go to there. Go to the index of s, that is size minus 1. So s at s size minus 1. That's how you do it. And this will give me back the character that it finds. And now I want to check, is that character a number? And there's a nice little library function for that called isDigit. Was that a digit character? You just call it and it gives back true or false. So I'm going to ask, is digit s at s size minus 1? And this will give back true if this character that I just put inside of this function and called it with as an argument was in fact a digit character. Okay? See, I'm chaining all these calls. So that will work. So you kind of can read it from the inside. This is an index. Then we're going to that index, getting the character. Then we're taking that character and asking, was it a digit or not? That's the order of those that execution. Right? I guess it kind of reads from left to right too. So now, if I just type my name, does not end with a number because it goes and it finds the n. Is digit on the n returns false. But if I do ABC123 or something, then it does end with a number because it goes and it finds the 3 character. It notices that, hey, yes, that is a digit. It's true, so it runs the true branch body. All right, so that's another helpful library function and a good example of showing how you can chain a bunch of calls to things. Any questions about that one? All right. If we're happy with strings and ints, let's go to doubles. There's an issue with doubles that I need to tell you about now so that you don't run into this issue later. This will come up in a future lab for sure, if it hasn't already bitten you already. But here's a very fun example. Let's add 10 0.1s together into a variable. So, all right. I want to make a file called doubles.cdp. This is a silly thing that I want to do. Double. It's not going to work. 0.0. D plus equals, that adds in a number into the variable, plus equals 0.1. So 1 times 2, 3, 4, 5, 6, 7, 8, 9, 10 times. If I were to print D right now, what should it print? What do we want it to print? Yeah, it should totally print 1, right? I've added 10.1s. But if we go with the full precision of doubles, and that kind of gives away the problem, doubles don't store numbers in a normal way. It stores it with a certain amount of precision. You can't store infinitely long chains of decimals. For set precision, I need IO minute. There we go. Now I have set precision, the max 16, and then I'm going to print D. Drum roll, please. It is not 1.0. It is 0.999916 It's not exactly equal to 1. Disgusting, I know. Let's talk about that. So, doubles are called floating point values. They take up 8 bytes of space, and so they can't store every possible number perfectly. You're trying to use a double to store any possible scientific notation number. It can only remember 16 digits of precision, and some information is going to get lost when you store it like that. Okay? You got to give up some numbers to store other ones, and 0.1 cannot be represented perfectly as a double. That was the problem. 1 can, 0.1 cannot. All right? And so that's why we lose some information when we add it a bunch of times. We get 0.9999. So it's still close to the correct answer, but it's not exactly equal to anything. So what you cannot ever do with a double and expect it to work is ever use equals. You cannot check for exact equality on a double ever, okay? Because of this problem. It will never be exactly equal to 1.0, most likely, right? Because some information is getting lost when you make a double. It can only store 16 decimal places of precision, and that means sometimes you end up with this, right? That's too bad. So you cannot ever check for equality on doubles. Don't ever think about it. That's going to cause an issue. It will not, like this one, it's going to be false. Let me just prove that to you so that you never do this again. Oops. So, do something like this. Let's just see out. See out, hey, is D equal to 1.0? As it should be, right? You might think. And of course not. 0 for false. And so you cannot have that like this or something. You can't be like, if D is equal to 1.0, blah, blah, blah. This is a horrible idea. It will most likely not be true, even if the number was supposed to be 1. Okay? No, yeah, it still wouldn't work. That would be the same number, and it's just not precise enough to store it properly. It's a base conversion issue, actually, if you want to think about it. It's being stored as binary. Think about how you might store a decimal number in binary notation. Like, what's 0.1010 in binary decimals? Try to go the other way in my conversion. And so it's... Oh, shoot. Well... Sorry about that. How long has it been off? Just as you said it? Oh, thank you. Okay, thank you for catching it. All right, I've learned that... This is new this semester, of course. I learned that if I unplug this, it suddenly becomes happy sometimes. So, all right. Well, that's computer science for you. So, okay. Yeah, it wanted me to get some exercise. Obviously. Darn. Well, all right. So that's the idea. So what do you do instead? I want to check if this number, I can't check if it's equal to 1, but I'm expecting it to be 1-ish. So what you need to do always when you're comparing doubles is, if you want it to be 1, if you're looking for 1, just check if that number that you got and are comparing is really close to 1. All right? Because it's not going to be like 0.8 or something. It's going to be 0.999. So just check if it was close to 1, and that's what you want to put in your if statement. All right? So just like, here is your number line. Here's 1.0. You're not going to get exactly 1.0 with doubles, but just like pick a range. Like, all right, I will accept this as being 1 if it's between like 0.999 and like 1.001 or something. Like, pick a range that's very close to 1, and just check if that number is within that range. That's what you want to put. All right. And so the way to do this is to use absolute value. So like, you got your number, and like, I want to check if d is very close to 1, so let's subtract d from 1, or subtract 1 from d, and just make sure that that's really, really small. Okay? This is your condition now. This is what it becomes. Just see if the difference between the number and what I want it to be is super small. That means it's within this range on the number line. Okay? Hopefully we've seen that in a math class before. But that's how you do it. And so let me show you that. It's going to be the f_abs function in the C math library. I think you've been reading about that, if I've got my timing correct. But you got an f_abs function somewhere here, which just computes the absolute value of a number. It takes a double, and it chops off the decimal places. Or not, no it doesn't. It just makes it positive. Excuse me, sorry, I'm thinking of mon in my mind. There's another one that does that. So it takes a double, it gives you back the positive version of that double. Absolute value. That's perfect. So let's use that. Let's watch that work. All right, it's not exactly 1, but what if I try this? See out, take f_abs of d minus 1. That's what I want it to be, and just make sure that's super small. That difference between the number and what I want it to be. You can go even smaller than 0.001. You can give a few decimal places. It's still going to work. All right? Oh, thank you. Yeah, it was confused. Getting ahead of myself. C math is where that function lives. So now, hopefully, yeah, there we go. Thank you. Yay, so I get 1 for true. Yes, that was true. It was very close to 1. It wasn't exactly 1, though, right? So hopefully this scares you enough to, whenever you have a double and you're trying to compare it, it all works out. You got to remember to do it in that way. Okay? Let's see. So that's that one. Let's try this one. I gave you a little piece of it before. Let's do a full grade calculator. Let's get a grade from the user as a percentage, and we're going to print A, B, C, D, or F for that number. And here's the range between 90 and 100 is an A, or maybe you can do like between 90 and infinity is an A, like extra credit counts. That works too. But this range is a B, 80 to like 80.9999. Try that. C range, D range, F range. That's like the range for this class's grade. And I want you to get a grade from the user. Maybe it's 85.5. And I want you to output B. Right? Regardless of the grade, make a big long if else that does this. Right? I will give you a minute head start or so. See if you can come up with the scaffolding before I do. and then I'll start writing my own version. Or maybe that's not enough time. Let me say 2. Let's have that be 2 minutes. Sorry. All right. Well, let's do it. I will call this grade.cpp. So I'm going to get a percentage from the user. Should I call it that? We'll call it grade. Call the variable grade. So let's ask the user for a grade. Store as a double, of course, because it might have a decimal place. And then let's get it. And all right, time to check. So this is the right order to be checking these things in, by the way. It lets you get away with things. And so it's an A if it's greater than or equal to 90, right? You don't want to start with like you don't want to start with like B out of order, because if you say something like it's greater than or equal to 80, then that counts for 100 too, right? So there's a way you can use an and, like if it's greater than or equal to 80 and strictly less than 90, you really can do it out of order now. You know how with an and, but you can save work by just talking about one half and using else. So if grade is greater than or equal to 90.0, why not? It's an A. Else if otherwise, if that wasn't true, we know it's strictly smaller than 90. It must have been at most 89.999. So this is a good chance to do the B, because I get that 89.999 check for free by the false of the first condition. So I can just check, hey, if that wasn't true, is it greater than 80 or equal to? In that case, it was a B. And then that's the game you just keep playing. It's like, all right, if otherwise, if that wasn't true, it must have been strictly smaller than 80, up to 79.9999. All right, if it's between that and maybe 70, then it's a C. So you can make use of the previous condition failing in your next one. It's pretty nice. And so same for D. Great. If it wasn't greater than or equal to 70, it must have been strictly smaller. And if it's between 70.9 or 60.999 and 60 itself, then we're good. There. So that's a D. And then finally, if none of that's true, if it's strictly smaller than 60, you don't even need a condition anymore. If that wasn't true, it must have been smaller, so C out F. So that is your grade calculator. Does that make sense? That's one way to do it. You can do it out of order now that you know about and. It's like, is it greater than or equal to 70.0 and strictly smaller than 80? That would work. Enter a grade, I don't know, 105, A, 95 still an A. 85 is a B because it's not greater than or equal to 90. It tries this one, and okay, now it's true. Same with like 75, 62.5, and then 55 or something. Okay, so that's a good order. It makes it look pretty clean, I think. Any questions about that program? Is that what we thought of in our minds? All right. Here's a fun program that's near and dear to my heart. It's like one of the first programs that I ever wrote by myself without anybody's help. It's a guess the number game. We're not gonna do it completely today. There's gonna be a piece missing still, but it's gonna work at least. But I was very proud for writing this program, so I'm gonna pass it along to you, the knowledge. So, all right. So we're gonna have the computer, right? This is a guess the number game. So the computer is gonna think of the random number. It's gonna like generate a random number and not tell us. It's going to hold on to it in like a variable or something, like we're going to make an n variable. It's going to hold our random number that the computer's thinking of. And then we're going to ask the user for their guess, right? And we're going to play this game. Like, all right, we're going to get a guess of like, we're going to guess 50 or something first, because that's like the right one to guess the first time. And then the computer is going to compare the number that it's thinking of and not telling us to our guess and be like, oh, you guessed too high, guess lower now. And we're just going to have it play the game like that. All right, so that's going to be fun. So we're going to generate a random number, hold on to it, and we're going to ask the user for their guess, and we're going to just compare, see if it was too high, too low, or just right. All right, so that'll be a guess the number game. We are capable of at least doing the first 2 bullets. So I'll call this guess.cpp. So I need randomness. So C stood lib for the rand function and for sran. I want it to be a different game every time. So C time. So I can seed the random number generator, srand time 0, with the current time, so that when I call ran, it's a different number every time I run the program. So remember that this line seeds the random number generator. And then we're ready to call rand and get our random number. So this is the number, we'll call it n, that the computer will be thinking of between 1 and 100. So we're going to do mod 100. That's going to give me a number between 0 and 99. I want a number between 1 and 100, so I'm going to add 1 to that. And I don't need any parentheses because we know that modulus binds tighter than addition. It's going to happen first. All right, and then we need a guess from the user. So I'll just make room for it right now. And so the game goes, like we're going to ask the user for their guess and compare it to the number we're thinking of, the secret number stored in n. Ask the user for a guess and see if it was correct. So see out, enter your guess. We'll get it. Oops. And now we have it, we can compare against n. So, all right, if the number... if the number that the user guessed was less than the number that we're thinking of, then we got to tell them to guess higher. They guessed too low, all right? Like their guess was 12 and the secret number was 42 or something. If this is true, then they guessed too low. Too low. New line. Otherwise, maybe they guessed too high. If the guess was bigger than the number we're thinking of, then like they guessed 87 when the number was 42. Got to tell them it was too high, all right? And then, otherwise, if none of that's true, see out. If it wasn't less than, it wasn't greater than, it was just right. They got it. All right? You got it. New line. All right? So that is kind of the program. It's a little bit of a problem. Let me show that to you. But it works. Guess. CPP-O guess. It's a little game. All right, enter your guess. 50. Too low. Program's over. We don't get a chance to guess again because when you rerun it, it's a new random number. So you have to get it right the first time. That's no fun. All right. So okay, we want to let the program continue. We want it to keep going, and have it ask the user multiple times if they still haven't gotten it correct. Right? Because if I run it again, like if I guess 50, maybe now it's too high or something. I don't know. Because it's just stopping the program and making a new number every time I run it. So it's a different number now. I want to keep the program running, keep the user guessing as long as they haven't gotten it. So we'd like it to continue. And the only way, sadly, we know right now to have our program continue is just to add more lines. So let's just copy and paste this as many times as we want the user to potentially guess. Oh well. This is leading into a nice concept that will be the next set of slides. So, all right, this is going to look a little ugly, but oh well. And so let's just, all right, if they didn't get the first time, let's just ask them again. Do all this code one more time. Why not? And then this gets into an issue of like, if they got it up here, it's still going to ask them because that's just the next code. So an easy way to have it, like if they ever get it right, just don't ask anymore. Don't continue with the code. Just stop the program. There's an exit function in the C standard library. Just call it exit and give the number that you would have returned like as your exit code of your program. So exit 0 is the same as stopping the program. Like our return 0 at the end. Stop the program. You could also just say return 0 here, by the way, because we're inside of main. But exit, I want to get you in the hang of using because no matter where you are, once we start writing our own functions, exit's always going to stop the program, right? So once the user gets it, stop the program so that we don't ask them anymore, right? So that's the code that I want to copy and paste a million times. So, all right, that's 2 times. This is 4 guesses now, potentially. Here's 8 guesses. If you play optimally, you only need log base 2 of 100 guesses, but we'll give the user a few extras. Here's, I think, let's give them 16 potential guesses. I think I've doubled it that many times. So now we have a program that is 205 lines. It's just the repetition of this. All right, get a number, check it, print out the response. If they got it, stop it. But if they didn't get it, keep going. Ask them for another guess because we got to hold on to that original n variable. We want the program to keep running. All right, enter another guess if you didn't get it. Enter another guess if you didn't get it. Stop the second you do, though. And so now we can play the game. Now it's going to work. We get 16 guesses max, though. It's whatever you hard-coded. So let's compile and run now. All right. 50. Too low. All right, 75. Let's try to do this right. Too low. 85. 95. Ooh, it's up there. 90. 89. 88. So apparently the special random number was 88. And if you play it again, it's going to be different. But you only get 16 guesses right now. That's what we hard-coded. So if you were a bad player of the game and you kept guessing 50 16 times, the program would end without you ever winning that game. All right? That's no fun. Let's see if there's still time to win it. 12. Oh, all right. Sweet. So that's the game, though. It's going to work. You just got to copy and paste. It looks a little ugly. You get a maximum number of guesses, but it's kind of fun, right? That's useful. That's like something you would want to program. That's the game so far. There's a way to make it less ugly. We'll talk about that in the next slides. But are there any questions about this program that we have it written here? As it is today. All right, that's a fun one. Try it yourself. I'll give you this code. 2 more slides for the day. I want to talk next about running code in your mind, because that's how you get good at programming. Like, you have a computer in front of you, I know, always, but just being able to understand how code is going to run makes it so much easier to write new code. I promise. So I want to get you in the habit of like understanding, if I give you some weird looking thing like this, understanding exactly how it might run, depending. Okay? So here's like a line A. Let's draw the flow chart for how this program is going to execute. It's going to do line A first, and then it has a big if-else. Okay? So line A happens first. That's the first line. And then we have a big if-else statement, and then we have line J. All right? So that's kind of the flow. But, all right, what's going to happen next? We have to run this big if-else. How do you run an if-else? You have to check the condition first, because that tells you, do you run the body of the if or the body of the else? All right? So now B is the next thing, and it's a condition. So it's like B question mark. Got to check B now. And if B is true, we go down the true branch, and we try C. So C would happen next if we went down that branch. You see I'm reading this? And then once we did that, we only do the if or the else. So if we went down the if, we skip over the else, and we're done with the whole if-else in that case. And so J is next. That's the very last thing that we do, the last line of code. It's like by itself, semicolon. And so let me put that way down here so that we can go into that later. It's always going to be the last thing to do. So that will be J at the bottom there. All right, if we didn't take that path, if B was false, what might have happened? All right, if that's false, we're going to run the body of this else, which has a lot of things. It has its own if else, then it has a line I at the bottom that always gets run. All right, so let's go through this. How do you run the first part, which is this big, long if else? Again, check the condition. Check that condition to figure out which body we're going down. So let's go down D. D needs to get checked first so that we can potentially go down this path. All right, so we check D. That's the very first thing to check. And that, if that's true, we're going to go and run its body and execute code E. And once we've done that, it's a big, long if else. It just runs the first body that works. If this one worked, we're done with this whole thing. Now we're ready for I. So we go to I. That always happens second. And then now we're done with the entire else, which means we're done with this whole big, long outer if else. And that means we're ready for J. So that was that path. There's more. See how useful this is? It's a little tricky, though. That's why we're talking about it. So, all right, we went down the D path. If this one was false, though, if D was false, we got to try the else if. So we're trying to pick one of these bodies to run if we're trying to run this if else. Maybe F was true. So we try condition F. F question mark. If that was true, because it could be true or false. If it's true, we go down G. We do its body, and then we're done with the whole thing. We just pick one of the bodies to go down. We pick this one. We're done with the whole thing, ready for I and J now. Boop. And then if that was false, if F was false, then finally we hit this else case, because we're working on this thing right now, this else, if else. If D was false and F was false, like we came down here and here, then we run the body of the else, which is H. And then after that's done, that's the whole if else, that's completed. Now we're ready for I, which is the last line of that outer else statement here. And so that means we're done with this whole if else, this outer one, and that means it's time for J. All right? So H feeds into I, feeds into J at the bottom there. So that is every possible path that the code could take and run, depending on those conditions. Are there any questions about how I did that? I know it seems a little odd, maybe a little tricky, but please try this yourself. It's very good help, very good practice. All right? Any last questions about any of that? Because my last example that I want to show you is just another website. It's really, really cool. It's called C++ Tutor. You can search for it on the internet. It's just like, it's part of a website called Python Tutor, funny enough. C++ Tutor should be one of the first links. This one, pythontutor.com/cpp.html. And what you can do here is you can type a program. The program cannot take input, so if you have any C inlines, you got to get rid of those and just hard code values. So let's take our grade calculator program and we'll change it up. It's hard code a value instead of like asking the user for something, because this website cannot take input from the user, but you give it a full program. Just going to put it in here. And instead of having it enter a grade, let's just hard code the grade at like 75. All right, so no need to enter it anymore. So that's my program now. And what you can do with this helpful website is click Visualize Execution. This will help you mentally make that flowchart. It's going to walk you through how this code runs. This is going to be really, really helpful going forward. So please use this website. It's going to save your life. So you type in this program, get rid of any possible CNs, got to hard code things, and then it brings you to this window, and you can just keep typing next, and it shows you variables. Like here's a variable grade. Ooh, watch. And then here's an output window. If there was output, there's about to be output. So let me scroll. So let me type the next button. Click the next button. So now we're on the first line. We're about to run it. Click next. It just ran it, and it drew what happened. Isn't that so cool? So now grade is set to 75. It's showing you that. All right. And then it's trying to run this big, long if else. If you've forgotten how that works, just click next. Like, all right, the first thing it's going to do is check this condition. Is 75 greater than or equal to 90? No. So now it's going to go and try this condition. See how it's showing you exactly how this code is running? All right, let's try this one. Is grade greater than or equal to 80? No. All right, let's try this next condition. Is grade greater than or equal to 70? Yes, and so you see that it went down into the body. this website's going to save your life. Next, so it prints C to the output, and then it's done with a whole big long else, if else, if else. It found its body to go down, and then returns 0, we're done. Program over. And so if you have a very fancy program with a lot of variables playing with each other, and like a bunch of if else's, you can just click next a bunch of times. It will tell you exactly why those variables are getting that value, why you're seeing the output that you're seeing. Very, very helpful website. Please use it. All right. Questions about that? One thing you got to do is get rid of any input, because you got to have a program that runs to completion, because it's trying to like draw what happens, so it can't like wait and ASCII for something. All right. If we are happy, that is all for the day. No new assignment. I'll give you your next lab on Thursday, so the rest of the time is yours to work and to ask questions.